Hey, welcome back. So I think we skipped this slide, so it makes it a good place to start up with here on our second half of significant digits. Probably the longest video of the year, also might be one of the most important ones. So that's why I've divided it into two sections here, And now let's take a look at working with some of the operations, adding and subtracting. All right, when you're adding and subtracting, the rule for significant digits is that your measurement can only go to the number with the least decimal places. Easier shown, I think, than said. So here we have an example, 61.2 meters plus 9.35 meters plus 6 meters. So let's start by identifying the placeholder in each of these measurements that is the least. So for example, our 61.2, the tenths place is our least decimal place. We go to 9.35, that's our hundredths column, and 8.6, that's back to our tenths column. At this point, I'd advise you to just go ahead and throw the whole number, every number, into your calculator. Don't try to round or anything until you get to your answer. So we add 61.2 plus 9.35 plus 8.6, and hopefully your calculator read 79.15. Now the idea with the addition-subtraction rule is that our last significant digit can only be as accurate as the least accurate, or precise, measurement. So we have 61.2, that's in the tenths column. We have 8.6, that's in the tenths column. Guess what? Our answer must have its last significant digit in the tenths column. So I'm going to round 79.15. 5 is big enough to have me round up. 79.2 meters. Now my last digit is in the tenth spot, and that works because 8.6 and 61.2 go only to the tenth spot. Doesn't matter that this one goes to 9.35, the hundredths spot. We're limited to the tenths spot. All right, I think we did most of these examples in our last video. So we go ahead and skip down to the last one here. 9.44 minus 2.11. Again, throw it into your calculator. That's absolutely fine. But when the answer comes out, we have to look. We have to recognize, okay, 9.44 goes to the hundredths. 2.11 goes to the hundredths. So our final answer should go to the hundredths column. 1.36 plus 10.17. 1.36 goes to the hundredths. 10.17 goes to the hundredths. So again, our final answer should go out to the hundredths column. 34.61 minus 17.3. Although 34.61 goes to the hundredths, 17.3 only goes to the tenths. So I want to make sure that my final answer only goes to the tenths spot. So I'm going to round my final answer to 17.3 meters. The rules change when you get to multiplication and division. So now it doesn't matter what placeholder the last significant digit is in. Now it matters how many total significant digits there are. So first example, 7.55 times 0.34. Again, you're welcome to throw that into your calculator, but we have to go back when we get our final answer. This first number has 3 significant digits, no zeros, 755, all significant. The second number has 2 significant digits, the 3 and the 4. Remember, leading zeros are not significant. So when I throw this into my calculator spits back 2.567. But looking over here, my final answer can only have 2 significant digits in it. I'm limited to the total number, which is 2. I need to round that 2.5. I look at the number after it. It's a 6. That's enough to round it up. My answer is 2.6 meters squared. All right, 2.10 meters squared divided by 0.70 meters. Again, 3 significant digits in our first number here, only 2 in the second number. So zeros on the left, leading zeros, never count. Zeros on the right, the trailing zeros, count when there is a decimal. So this 0 does count. This 0 here does not count. So again, I can go ahead and throw this into my calculator. Now watch out for a problem like this. 2.10 divided by 7.70, your calculator is going to tell you the answer is 3. But you're going to have to be smarter than your calculator. Guess what? Not only am I limited to 2 digits, but I have to have 2 digits as well. If my calculator says 3, I need to know I need to put one more significant digit on there. How do I do that? Add a 0.0. Now it's a trailing 0 with the decimal present. Significant. 2 significant digits, 2 significant digits. We're in good shape now. All right, let's take a look at a few more examples with multiplication and division properties. 8.3 meters times 2.22 meters. Again, we can go ahead and throw it into our calculator. Take a look at our significant digits. The first number only has 2, so we need to round our answer to 2 significant digits. I've listed it in scientific notation. And then watch your unit on this one also. Meters times meters is meters squared. Again, so I've got it in scientific notation, but you guys are welcome to put it in standard notation. Just say 18 as well. Second example, 8,432 has 4 significant digits. That's meters squared, divided by 12.5 meters. 4 significant digits, 3 significant digits. Again, you can plug it into your calculator and get the actual answer. But 6.75 times 10 to the second meters. So meters squared divided by meters, you only get meters back out. 3 significant digits, 3 significant digits. Oh, just noticed also that they did ask us to put it into scientific notation, so it does have to be in scientific notation. All right, taking a look at our last problem here. We have 35.2 seconds times 1 minute per 60 seconds. Hey, remember, this one here is one of those rules where that is an exact number. This does not have any significant digits in it, or it has infinite significant digits. Either way, we're not going to limit ourselves to the number of digits we see here. That is an exact translation. So we go back to the beginning, 35.2 seconds, that is a measured amount. There are 3 digits there. So 35.2 divided by 60. I know it's a multiplication symbol, but we always divide when it's on the bottom like that. 5.87 times 10 to the negative 1 minutes. So again, 35.2, that's 3 significant digits. There those 3 are, 5.87. We talked about this yesterday when we did our percent error. Hey, here I've got my values listed. I'm reading the question. I'm listing my values. The accepted value is 2.20 meters. The experimental value is 2.14 meters. If you guys remember yesterday, I made a big deal about showing this step right here. I know a lot of you guys don't like to do it, but here's why it's so very, very important. If you just plug all this into your calculator right from the get-go and you press enter, you might get the right number, but it's not going to be the right answer with significant digits. This is a mixed operation problem. So again, you might be thinking, we're doing a division. There's 1, 2, 3, 1, 2, 3, 1, 2, 3 significant digits. My final answer should have 3 significant digits in it. And again, that's wrong. That's going to cost you half of a point for significant digits, plus another 2 or 3 points for having skipped this step. Guys, when you have a mixed operation, make sure you do the mixed operation problem separately. 2.20 minus 2.14 yields 0.06. Guess how many significant digits? Did I do anything wrong there? No, absolutely not. My last significant digit is a 0. My last significant digit is a 4. They're both in the hundredths place. So when I did the subtraction, I ended up with my last significant digit in the hundredths place. Is it okay that I lost 2 total significant digits? Yeah. Addition and subtraction, it matters where they're at, not how many there are. So I get to this point, both of these numbers are good numbers, but again, I'm now down to just 1 significant digit. Zeros to the left don't count. So I do my division, get this big, long, nasty number. See, I've got the number underlined. I only want 1 significant digit. That 2 right there is the only significant digit. I've underlined my digits down here that are not significant, and my final answer, 3%. Take a look at the 2, that's the only significant digit. This right here, 7 is enough to round up. There's my answer. So that's why it's so very important to make sure in mixed operations that you do and show both steps separately. Another example, same type of problem here. Again, showing you the same example. We have to show this step. Made a big deal about it when we covered percent error 2 days ago. Making that same big emphasis right now. Do that subtraction step first. 3.5. Is it okay that I only have 2 significant digits now? Yes. 21.2 minus 17.7. Both those numbers have 3 digits, but that doesn't matter in a subtraction step. What matters is where the last one is at. The last one should be in the tenths column. There it is. That 5 is in the tenths column. So 3.5 is perfectly all right. Now I've only got 2 significant digits. When I divide it by 21.2, I get 0.1651. I underline my insignificant digits. I only want 2. There they are. There's my 2 significant digits. My final answer then, 16.51, not my final answer. I'm going to put my final answer in a box, always, always, always. 6, rounded up to 7, 5 is enough. There's my final answer. Again, make sure you guys are putting it inside of a box so that I know which one to grade. If you left both of these answers out, I might say, too many digits. So final answer goes in a box. All right, quite a lesson here, significant digits. In this particular video, we focused on multiplication and division, but quite an overall lesson. Hey, they're a pain in the butt. I get it. I know they're a pain in the butt. But if you're willing to think about them every single step, which you kind of have to anyway, eventually you start getting better at them. And that's the whole name of the game. Practice makes perfect. So keep thinking about them, keep practicing them, and everything you do. It's kind of how chemistry works.